All right, guys, so we're going to move into the next section here dealing with angles, arcs and their central angles. Um, so let's jump into that and see where things go. All right, so first of all, we want to understand a central angle. A central angle just means that, well, the vertex is at the center of the circle. That's all it means. Now, if we look at this angle, notice that when we extend the sides, it's sliced off an arc, a part of that circle. So we want to create this relationship between the angle and its arc, the one that it slices off. We always draw angles all year long. We've been drawing angles and putting little arcs in them. So now that arc is really just part of a circle, and we're just saying this angle cut off that arc. As we talk about arcs, we want to be able to classify them. So we could have a small angle, a small arc. We could have a big arc. We could have a lot of different things going on. So we want to talk about that. We want to talk about the types of arcs. So we classify those arcs three different ways. A minor arc is less than 180 degrees, so less than halfway around the circle. A major arc is more than halfway around the circle. And if it's exactly 180 degrees, it's a semicircle. Remember, measurement of an arc is in degrees. We're not talking about the length of an arc. That is completely different, coming soon. We also want to be able to name arcs. So we always name arcs by their endpoints. No, we don't need points along the way other than to distinguish which direction we're going. For example, if you look at the picture and I said arc AB, you wouldn't know if I meant go the short way or the long way. So we have to have some rules. Whenever we use 2 points, we're going to go the short way. So arc AB means start at A and go the shortest way to B. You might pass through some other points, but you're going to go the short way. If I wanted you to go the long way, so A, but the long way around to B, I'd have to tell you start at A, pass through D, stop when you get to B, and you're following the curve, so it's an arc. So again, if there were other points along the way, I don't need to name go start at A, go through E, go through D, go through Q. We don't need that. Starting point, some point that you pass through, and then the ending point. So 2 letters, it's definitely going to be a minor arc. It could be a semicircle, but that's a really bad habit. 3 letters, you just follow in order. Again, the big giveaway is 2 letters, you go the short way. We'll see some of that as we go. So let's look at a couple quick examples here, right? And we want to name a few arcs. So name 2 minor arcs. Well, think about that. Minor arc, less than halfway around. So for example, I could start at B and go to C. And I have minor arc BC. I could have started at B and went to D. That's fine. If I wanted to, I could start at C and go to E. And again, it's not about clockwise or counterclockwise. It's about how far around the circle we go. So there's a few more, and you can certainly think about those. We could talk about major arcs. Major arc means more than halfway. So let's talk about a major arc. A major arc would be something like E, and I'm going to go more than halfway. B is halfway, so I'm going to pass B, and I'm going to go to C. Well, again, 2 letters means go the short way. We went the long way. So we started at E, we went through F, and we kept going around until we got to C. In fact, we could have said start at E, go through B, and keep going till you get to C. That's fine. But we have to indicate don't go the short way. Pass through this point on your way. And again, there's a couple other major arcs in there. Those are actually the same arc. So if we wanted to name another major arc, For example, we can say D, the long way around, stop when you get to E. So maybe D, pass through C, stop when you get to E. And then, of course, we're asked here to name semicircles. So if we're going to name semicircles, a semicircle is halfway around the circle. So the giveaway here is look at our diameter. That cuts a circle in half. So our semicircle is E, go this way to B, and the other one is E and go this way to B. So we could call it semicircle EB, but we wouldn't know which half, the red or the blue. So we try to be a little more clear. We might say EFB. Sorry, EFB. Or we might say something like EDB. That way we know which half of the circle we're talking about. Okay. Well, once we have measurements for arcs, we can do arc addition. Just like we can do segment addition and angle addition, we can also do arc addition. If two arcs are next to each other, one just continues into the other, then if we know their measurements, we can add them. So for example, in this picture, let's see what we're given. Arc AB is 50 degrees. BE is 70 degrees. So we have our two arcs. Well, we can add those together. 50 plus 70. So arc AE is 120 degrees. We can find some other arcs also. For example, we have arc ADE. A through D, stop at E. Well, think about that. It's the circle not including the 120. So we can say 360 minus the 120. So 360 minus 120 gives us 240 degrees. And finally, we can even take a look at ADB. So start at A, go through D, and stop when you get to B. Well, it's the whole circle, not including the 50. So it's the whole circle, not including that 50. So 360 minus 50, leaving us 310 degrees. So that would be a major arc. Finally, what we want to do is create a connection between angles and arcs. And we started to on the earlier slide, and this is the same exact picture. Whenever the angle is at the center of the circle, so whenever we have a central angle, you always want to know where your vertex is. When the vertex is at the center of the circle, the angle is equal to its arc. So if this is a 40-degree angle, then we have a 40-degree arc. And again, we're not talking about length. Big circle, small circle, different lengths. But 40 degrees is 40 degrees. So the angle is equal to the arc. Always pay attention to where the angle is. In this case, we're focusing on central angles. Okay. And everything else now comes down to some practice. So let's take a look at what's going on here. We want to find the measurement of the angle or the arc. So let's see what we have. We're looking for that angle right there. Well, don't we usually draw a little arc in it? Well, here they just have a big arc in it. So it's 120 degrees. Angle equals arc. In the second one, we're looking for angle MIJ. So we want to find it, MIJ. Now, one thing here, and we've done this question plenty of times, It just wasn't inside of a circle. Check this out. We have a diameter of a circle. Look at that yellow Y. Isn't that just a linear pair? So that means they're supplementary. So the 55 and the angle or arc next to it have to add up to 180. The diameter cut the circle in half. So we have half of a circle, which is 180 degrees. So to solve this one, we're going to say x plus 55 equals 180, and x equals 125 degrees. Very similar question. We're working with the 140 and the one next to it. Well, again, there's our split. This is really just a chapter 1 linear pair supplementary. The only thing that makes it a circle question is that we can say the 140 comes out to the arc, and we're going to add the two arcs. So we have 140 plus 6x minus 8 equals 180, and then we can solve it from there. So what do we have here? We have 132 plus 6x equals 180. 6x equals 48, and x equals 8. Looking at our next question, we're looking for the measurement of arc CFD. So I want to find it. C. Now, I have to go through F on my way to D. So I have to go this way. And I'm following the curve. I'm not going to get to F and then cut through. I'm going to keep following that curve. So I'm looking for almost a whole circle. Well, how are we going to figure out the part that we don't want? There's a couple different ways we can do this. But one thing that I noticed right away in looking at this picture, there's a big X in the middle. And when we have an X, we know that we have vertical angles. We have vertical angles. So that means, think about this. 135 is equal to 81 plus the X. So now we can find out that slice, that little angle, which is the same as that arc. So 135 minus 81 is 54. And now we wanted the entire circle minus the 54. And 360 minus 54 leaves us 306 degrees for CFD. Okay. So let's put a couple practice problems into one picture. All right. Try these out. Come back to the video. So go hit pause. And now we can go over them. So we want to find the measure and classify. Well, let's see. Let's see what we were given so far. We know this is 70. So arc MN is 70 degrees, which is minor. We're looking for NQR. Well, if we look at it, N through Q to R, halfway around a circle. So that's 180 degrees. which is a semicircle. Let's look at QR. Just Q to R. Trace it back to the angle. And look at that. It comes from a vertical angle. So this 70 is the same as that 70. So QR is 70 degrees. Also a minor. So we have vertical angles inside that circle. QMR. So Q through M and keep going to R. Well, look at how much of that circle I just traced out. It's the whole circle, not including the 70. So we get 290 degrees. 290. And 290 is a major arc. And then finally, we have PRN. So let me find another color here. PRN. Getting a little messy. P through R and keep going around to N. So we don't want this part. Well, again, we can do a lot of different things. We can add them up as we go, or we can figure out that part and subtract it. So here's a couple different things we can do. We can find our diameter. We have 70, 30, and the one we don't want. Well, 70 plus 30 plus x is 180. So that means this is right here is 80 degrees. Finally, we can say, well, we want the whole circle, not including that 80 degrees. And that's going to give us a 280 degree arc, which is a major. So in these questions, sometimes we're finding the missing piece so that we can subtract it out of the whole circle. Now, again, we can add as we go. There's nothing wrong with that. So we could say 30 plus 80 plus 70 for 180. Or we can put a 70 over here and we can add things as we go. 70 plus 80 plus 30 plus 70. Or we can say the whole circle minus the part we don't want. Okay, so we did some good practice. Try your practice problems tonight, and we will pick up with things from there.